Yeah, the microphone was off, so now I'm gonna present you once again from University of California, the doctorate student Santa Cruz. Batu Aytemiz is together with us. Now he's gonna present a topic on machine learning and artificial intelligence. Welcome once again.
Ben daha geniş bir gruba hitap edebilmek için bugün sunumu İngilizce yapacağım.
Yeah,
Ama
I'm going to make my
şu an
presentation in English,
tavsiye
but I
ediyorum.
can answer you
So,
in
uh,
Turkish.
if that's the case, without further ado, let's get started. Let me just share my screen and then get some settings. Okay, awesome. Hello, everyone. Thank you for coming. My name is Batu Aytemiz, as said. Let me start my watch. Okay. And today I'll be talking about the today and tomorrow of machine learning in the games industry. Okay, so before we get started, let me tell you about who am I. I'm the vice director of Inog. Inog is a game development community in Turkey. We're working on developing games. Let's go with that. And I also write our weekly blog and weekly newsletter, and I edit all that. And you can find it online if you go for Inog and blog. And I'm also a PhD student at University of California, Santa Cruz. And the lovely banana slug that you see in the background is actually our mascot. So that's why it's there. And my research during my day job is on game design and also artificial intelligence. Unfortunately, though, my AI agents, the artificial intelligence systems that I create, aren't really smart as the ones in Westworld, but they're more like this. They bump up into walls often. Today, I'm not going to talk about my own specific research, but if you're interested, you can find out a summary of what I do in this video. And roughly speaking, what I do is I work on game inclusivity. So I use AI techniques to ensure that no one feels helpless playing games. And this takes the form of having better tutorials to educate the players in how to play the game, or making assistive systems to help players play the game. And aside my PhD work, I'm also a game developer. So I mostly join game jams and I create 2D games. Have been lately. This is a game where you pour police officers on top of strikers. Stories there, and some other projects. And aside of my own own game development practice, I was very lucky to work in some companies. One was Ubisoft Montreal. I worked at LaForge for 5 to 6 months, and LaForge is the research and development arm of Ubisoft Montreal. And I was mainly focused on reinforcement learning and navigation. And I also spent a summer in Microsoft Research Cambridge in the Game Intelligence Lab. Similarly, Game Intelligence Lab is looking into using AI techniques to empower game developers and create better experiences for the players. And in this project, my focus was looking into aesthetic style of our reinforcement learning agents. And fingers crossed, assuming these problems are solved, I'll be at UnityML agents this summer. But without further ado, let's talk about what we're going to talk today. First, I'm going to give you a high-level intuitive overview of what machine learning is and what it isn't. And then I'm going to give you a sampling of ML techniques that are used in the games industry today. And I think the most exciting part of this talk is going to be giving a survey of possible AI interventions or AI improvements that we might see in the games industry in the upcoming years. All right, let's get started with what machine learning is. So we need to take a step back first and then really understand what AI is. And these terms are very loosely defined. Whoever is working on these topics comes up with their own definitions. So there's no one set strict definition, but more of just like common consensus. Well, we can look at AI, artificial intelligence, as systems that imitate human intelligence to accomplish tasks. So back in 1999, there was a paper titled, "If It Works, It Is Not AI." So humanity has been trying to build AI systems since 1950s, and we haven't really been that successful in the last 70 years. That has started to change in the last decade or so. So hopefully now our AI systems also work. But yeah, so AI systems are trying to imitate human tasks. So what is machine learning then? Machine learning is a sub part of AI. So machine learning systems use data to learn how to imitate human intelligence to accomplish tasks. There are AI techniques that have nothing to do with data. Mostly they're rule-based systems. sometimes referred to as good old AI, where an expert system basically writes a set of rules and then the AI system executes on that. But machine learning specifically uses new data to learn what to do. And then there's this underlying layer called deep learning. And deep learning, you might be hearing a lot about deep learning these days because a lot of the big improvements and big shiny results come out of deep learning techniques. Deep learning is a subset of machine learning. There are other methods that you can use in machine learning, such as regression, support vector machines, and what have you. But deep learning specifically uses artificial neural networks to accomplish this learning task. And we don't especially care about deep learning in this talk. Although that being said, almost every project that I talk about will be using deep learning in one way or another. And machine learning is divided into roughly three chunks, not especially, but for our purposes today. One is supervised learning, denoted as SL. The other one is reinforcement learning. And the last one, generative adversarial neural networks. And these you can think of subsets of machine learning. Okay. So, and today our focus is going to be on that machine learning layer. And it's very important to note that this talk does not include data analysis for business decisions. A lot of what machine learning is used in game companies or any companies is to actually power the financial decisions and the economical side of it. That's huge and incredibly important, the analysis and prediction side there. But this talk will be focused on content and tools. Okay, so machine learning is played. Let's give a high-level overview of what we're talking about. And I'm pretty sure a lot of you have a rough idea, a good idea of what machine learning already is. A lot of data equates use machine learning. My thesis today is to break that. I believe that that is a misconception. I think there's a subtle difference that we all should be aware of. A lot of labeled data means that you can use machine learning. And then my goal with explaining what machine learning is, once again, is to switch you into looking at maybe your own project through this lens. How can I get a lot of labeled data and get some results that interest you? And there's a big difference, as you'll see. Okay, so some very simple math. That's a function, and that will be all the math that we see. And what a function does is the function f, in this case, takes in an input x, takes in the data x, and then it returns our output y. And that's, as programmers, what we do is we write them in functions. There's this function f that takes in the input x, and the programmer has to fill in these lines, so something happens there, and then we return the value y. So those are the only things. And for most of computation, for the last 50 years, this is the model that humans work with. So the human programmer supplied the function, so we wrote the function, and then we also gave what data the function was going to act on. And then the computer took those two pieces of information and then gave us a result. This could be a mathematical calculation, this could be an HTTP request, an internet connection, a database request, what have you. We write the function, we give the data to act on, the computer takes those things and returns us the result. And if you look at it here, the function is f and the data is x, of course. So let's imagine a problem, right? In our problem, we have players. This is our sad player and this is our happy player. And what we want to do, this is a playtest, let's say, we're recording the face our players consensually, and then we want to know whether they're happy or sad. That's the task we have. So a little bit more specifically, we want to create a function that takes in a photo of a person and then decides whether they're happy or whether they're sad. So in this perspective, our data would be the face, the photo, we would write the function, and the computer would basically tell us using the function whether the photo is happy or not. Let's try this out, shall we? If I want to write this function f, what do I actually need to do on this photo object? Photo is a series of pixels. First, I need to find if there's a human in the photo, right? Like it might be a photo of something else. Then after I locate the human, then I need to find the face of the human. I guess I can try to look for like circular outlines to find the face. And I guess if I'm trying to guess whether someone is happy or sad, the eyebrows are important. Like I need to find where the eyebrows are. Maybe I can use a line edge detector for that. And then I guess I have to check if the eyebrows are furrowed. Like if they're at a deep angle, they might be angry. But then again, like different cultures have different ways of responding to like anger. What happens if the person doesn't have eyebrows? Difficult. Another step might be to find the lips. If they're smiling, that's good. If they're like frowning, not good. And I have to basically combine these values, right? Let's say we have an understanding of how happy they are looking at the eyebrows and then looking at the smiling lips. And these are two numbers. I need to somehow combine them. And finally, I get the emotional state from the photo. This is really difficult. Like there are a lot of technically difficult things. For example, all the steps that I've described, but there are also difficulties that arise from coming up with a decision about like how much does an eyebrow frown versus a smiling relate to the person's happiness if we're looking at the image, right? And then there are also cultural differences that the encoded rules that we have might not necessarily reflect in other cultures. Because that's a really difficult task. Image processing is notoriously difficult if you're writing the rules in a traditional style. So what we do, we let the computer do it. We let the computer write the function f, because in this case, writing the function f is the difficult part. So this was the traditional setup. The computer was giving us the result. What if we want the computer to give us the function instead? So then we can give it the data, and that would be the photos themselves, and also the results. So for given photo, whether the person in the photo is happy or not. So if we can come up with a lot of labeled data, so the photo would be the data itself, and the tag happy or sad would be the label, we can actually train our machine learning system. And of course, we need a lot. And then our computer will give us a new function that maps faces to whether they're happy or not. And with that, if we can give it a new face, then it can tell us whether that is happy or not. So instead of doing a difficult work, we're actually using machine learning. And what I explained here is supervised learning to solve our problems. So why did I really talk this much about data, results, functions? Wasn't this something that you already knew? I think that the biggest misconception that I met while talking to people is that they miss the label step. So they believe that data alone is enough to create machine learning systems. That is not the case. After you create the data that you have, you also need to go and single-handedly label every single image or document or idea that you have. But now that if you start looking at your own processes, own data that you generate, and you can come up with some sort of data and the result that you want to predict, using that combination, you might actually use some machine learning techniques. And in the ML jargon, it is called data and label. Okay, so those are that's a high-level overview of what supervised learning looks like. Now let's see some examples of it used in the games industry. As of March 2021. This thing changes incredibly fast, so who knows what will happen next year. Okay, so the first result that I want to share with you is from Ubisoft LaForge. It is about cleaning motion capture data. So when you're capturing motion capture data, you have a lot of markers in your actors, but because the markers are occluded in most cases, when you're doing trips and jumping down, the data that you get is rather jarring. So the one that's on the left. So what Ubisoft did in this case was they got a lot of hand cleaned data. That was their data, and then they willingly broke it. So they created a data set of clean data and a data set of broken data. And then they tried to learn, using the broken data, let's predict what the actual clean version would be. And through that system, they actually created a system that can take in any type of motion capture data and then clean it very well. And this gave a lot of workflow improvements. I think when we're talking about AI techniques, often people think about, AI behavior of non-player characters. But these type of machine learning techniques can go much further and actually really help in the workflow and the pipeline part of the game development. And another thing ML is used for by 343 Industries today is matchmaking. So they have years and years worth of data about at what conditions, what time of the day, what time of the year, Monday, Sunday, whether it's holiday or not, about how many players are playing their online game and how the trajectories increase and decrease. So with that knowledge, they can actually predict or take make an estimate about how many players they're going to have at any given matchmaking moment. So they can use this information to ensure people don't wait too long, but they wait enough to find a good match with their players. And another way ML is used today is about finding visual bugs. So this is similar to the first project, where this project is coming from EA Seed, and Seed stands for Search for Extraordinary Experiences Division. You should look into their work. And what they do is they take a lot of shots, images in their game, and they corrupt it. So after the corruption stage, they have a data set of clean images and data set of corrupted images, and now they can look at the differences. And after they train this model to find the corrupt images, now they can just run that model loose in their game, and instead of paying unpaid interns to look around and find the specific or professional QA testers, which is a more proper way to go about it, to find these things, the AI system can do it. So the professional QA testers can focus on more difficult tasks and more valuable tasks. And this is another project from Ubisoft LaForge, and this is about lip syncing animation from dialogue text. So what I want you to focus on here is the how the lip animation actually matches what we're going to hear. I'm going to play a sound, so please lower the volumes of your headphones if you're using one.
You make jokes, but it is not funny. It is greatness I am after. This country is at civil war, one simply cannot deny it. Everywhere is misery.
Tu plaisantes, mais ça n'a rien de drôle.
And yeah, the cool thing is that this system works with a variety of different languages. And this saves animators a lot of time, because now they don't necessarily have to go and animate lips hand by hand, or use more difficult and cumbersome techniques. So this is once again a high level workflow improvement.
You make...
Right. And Valve actually uses machine learning to find cheaters. So they have, once again, a huge list of data about people who played in their games, and then they were deemed to be cheaters. And they're using the actual in-game movement of the characters. So this is on CSGO. And they're looking at how fast the cursor moves, how the actual movement of the character is, the kills they take, the deaths they take. So they're using that in-game information to at least predict or have an estimate whether someone is a cheater or not. Of course, the system doesn't automatically act, if I'm not mistaken, but they're flagged for further investigation. And finally, Forza actually uses neural networks to drive their cars. So one thing that is really cool about this is these agents not only drive very well, but they also drive in the specific style of any given player. So in Forza, you can basically race against your friends or race against players that are really, really good. And it's using neural network techniques, as we saw here. Well, one thing that you might recognize in this case is this. What Forza does is a little bit different, because they're not using supervised learning that we talked about up until this point, but rather they're using a different technique called reinforcement learning. So let's look into what RL is. And RL stands for reinforcement learning. So similar to our earlier systems, our machine learning system takes in an input. And in this case, let's say you're actually giving it the screen, whatever the player is seeing, the machine learning algorithm also sees the image of our driving game. And then what we want is the ML algorithm, the machine learning algorithm, to predict what button to press, whether the car is going to accelerate, whether it's going to brake, whether it's going to steer left and right and all that. So one way that you can go about doing this is a supervised learning setup, what we talked about. So if you create a huge data set of a human playing, like I can play it for 100 hours, ride around and basically record at what frame I pressed what button, you can make that connection, right? That would be a supervised learning problem. You would take in a data, what state we're in, what frame we're in, what image that is, and then you can look at like, oh, what did Batu press? Oh, we're coming close to a wall, then Batu press the brake button. Cool, that would work, except that has two problems. One, if the agent sees something that I have never done, maybe the agent somehow decide to go backwards, and I never did, then it becomes really difficult for the agent to recover from it, because suddenly it's an uncharted territory. It has no idea what to do, because in the data set that I personally created to train the agent doesn't include that. So that's one big problem, and that emerges very often. Um, and the reason why that emerges is because if there's a slight deviation from the track, if the agent makes a small mistake, then usually that leads to crashes or the agent going out of the way. But usually players are really good at staying on the track. So even though you create a lot of data on the track, you don't necessarily create as much data in crash situations. So it becomes really difficult for the agent to recover. But I digress. The other problem is if we're learning from my own data set, then the agent is not ever going to be better than I am. So the data set basically gives a strict high-level skill ceiling to the agent. And if I'm not really good and we need a really good agent, then that's not going to work. So instead, we use reinforcement learning. What is that? Instead of telling the agent predict what the human does, what we tell the agent is finish the level. And we say, if you pass through the finish line, you're going to get a +1 point. And if you don't, you're going to get a -1. And then the mandate that we give to the agent is maximize the number of points that you have. So this is very similar to the Pavlovian response in humans and animals. We do something. If you like it, I eat cake. I like eating cake. I say, like, let me eat more cake. Or if I put my hand in the fire, it hurts. That's negative reinforcement. I stop putting my hand in the fire. It's the same idea. The agent starts by taking random actions because it doesn't know how to do something. It knows what to do, right? Like it needs to cross the finish line, but doesn't know how to get there. But somehow through random luck, it actually manages to cross the finish line. And then it gets a +1 point. And it goes like, whoa, I got some extra bonus points. I need to figure out what I did to gain those points. And then it basically decides like, oh, I pressed accelerate button. That increases my likelihood of actually getting a reward. So let me keep doing that. And through this process, over millions and millions of in-game hours of training these agents, we can get agents that play really, really well. And that is called reinforcement learning. So in reinforcement learning, there's no explicit data set, but the agent itself, by acting in the world, creates its own data set. And this is why, because there's no designer-curated data set, the reinforcement learning agent can become really, really good, much better than any of the designers. So how does this look like? It basically looks like what we explained, right? So here we see an agent taking random actions, and whenever it is crashing at the walls, it is resetting. And after 3,000 iterations, the agent basically realized, oh, crashing is bad, and it is trying its best in taking the corners. But it is still not really good because, for example, in that curve, it really hasn't practiced that curve much. So it requires further training. And then if you keep training more and more and more, sometimes weeks, sometimes months, the agent actually reaches a good solution. Just to give you some anchoring context, one of the strongest agents, reinforcement learning agents, or biggest accomplishments was RL agents playing Dota 2, and they trained on roughly 256 GPUs for a month to be able to play Dota 2. A lot of game time. Okay, so what do we use these techniques today in the games industry? One is testing. King actually uses a combination of RL and supervised learning to test their levels. So you can find more about it in Human-like Playtesting with Deep Learning. It's a pretty fascinating paper, and there's a blog post. And EA, once again, EA Seed uses the same techniques, reinforcement learning, in testing larger scope games. So this is going to be a first-person shooter. And if I'm not mistaken, they actually rolled out this testing method in Battlefield 1. So here we see an agent that is navigating around, collecting ammo, and then fighting enemies. And once again, one thing that is important is the agent is only given the goal. The agent is told, okay, protect the goal, or kill the enemy, stay alive. And the agent has never been told how to do it, but through experience, it has basically learned that pointing at the enemies, pulling the weapon trigger is a good thing to do versus moving around. So you can see the complexity of the problem. Hearthstone, actually, I recently learned that Hearthstone uses reinforcement learning in its single player modes. And the reason why this is the case is because unless they use an automated AI system, wherever they introduce a new card set, then the AI engineers need to go back and then incorporate new rules to play those newly added cards. So this is once again a more focused on the workflow and pipeline problem instead of creating a really, really good agent. And here, even in this talk, Wayne talks about the goal is not about producing a superhuman opponent, but rather using these techniques to make the pipeline better. And finally, one of the ways that it is used currently is in navigation. So this was, I personally worked on this project, so I like it. This project is about navigating a 3D space in a physics-based movement system. Traditionally, you use navigation meshes to move around, but navigation meshes, while very powerful, they require some hand authoring, especially for linking nodes. So if you're jumping, dashing, if there are jump pads, a designer needs to come in and add those nodes. And verticality isn't very easily handled. But this technique is using reinforcement learning. The goal of the agent is basically to go to the goal, and the agent has learned how to move around, jump around, and can do rather sophisticated moves such as jumping outside the building and jump back on top. Okay, so this was a sampling. Obviously, it's not exhaustive, but I wanted to give you an idea of how machine learning techniques are used in the games industry today. But I think the exciting part of this talk is about imagining and dreaming what might come tomorrow. So the things that you're going to see from now on are basically research projects. And as far as I know, they're not necessarily put into production, but obviously I might be mistaken. And the first thing that we're going to look into is, once again, a reinforcement learning project. So in this project, it's a hide and seek game where there are two teams. One, red characters are trying to find the blue characters, and the blue characters are trying to escape. But one thing that is really cool in this one is how different strategies actually emerge. So that the characters can basically block and unblock boxes. So the blue characters learn to work cooperatively to block the different doors. And as a response, the red characters actually use the ramps to move around. So they figure out that ramps can move the walls. So the blue characters figure out how to pull in the ramps first and then block the walls. And even though the designers thought that was the end, that really isn't the end. When in an open space, the blue characters actually figure out how to build shelters. And as a response, the red characters figured out how to surf on boxes. I think this is the part where things get interesting, right? Like all the things that we talked about, like blocking the walls and whatnot, was intuitive. But this is a emergent response that the agent has found. They basically broke the physics engine by jumping on the box and then pushing the box, to do something that is unexpected from the game designers. Oh, the videos. All right, let's try this again. All right, yes, shelter construction. Here we see the character actually surfing on the box. And as a response, the blue characters actually start locking the boxes. So now the agent cannot surf. Cool, okay. And another thing that I wanted to show you in this video is the bloopers, where box surfing was one way an emergent technology emerged, but there are other cases where the agent basically broke the physics system and ran away. So here the ramp is glitched out. Here, the agent basically glitches out the physics system to jump itself, and so on and so forth. So these type of agents can discover new techniques how to play the games, but also discover bugs in your game. So pretty exciting. Another way to look at it is co-creation. So here we're looking at a research project from Matthew Gazile, and he's using a reinforcement learning agent to co-create a level. So what that means is whenever Matthew makes a change on the map and then presses end turn, the agent actually looks at what the map is like and then tries to continue the map. Initially, it's not really good because it doesn't know much, but with each decision that Matthew takes, the agent is getting some information. So after a longer workflow, the agent is learning to replicate some of the steps that Matthew is taking. For example, the agent just continued the top wall there. And you can see that a lot of the AI research, when we think about it, is on automation, but a more productive, I believe, way to engage with AI techniques is about enhancement. So how can we use AI techniques to enhance our developers, our designers, and what have you? So up until this point, we talked about supervised learning and reinforcement learning. And there's just one last category called generative adversarial neural networks that I would like to mention. So supervised learning, you have a data and a label. In reinforcement learning, you have an agent that does random things. And generative adversarial networks are really good at procedural generation, meaning you use these things to create content. And in both of these, the output was one bit of information, move right, move left. That's a button press, and then a label, happy, sad. But generative adversarial networks are useful in creating whole content. So this is a photo of a person, except it is generated by a neural network. So this person just does not exist. So how does a GAN work on the highest intuitive level? You can imagine a GAN as a person who's trying to create fake money. And that person has a lot of real money they can look into. So they're going to create something that is similar. And the way that they're learning is they create something that is fake, a forgery piece of money, and then they give it to the police, or somehow police gets it. And then the police says like, oh, this is real money and this is fake money. And the thief, the forger, basically says like, oh no, the police figured out my fake money. Now let me update my fake money to make it look more like the real ones. And if the police at some point stops being able to differentiate the real one from the fake one, then it means that we have a forger that is really good at creating real looking stuff. So let's say we have a huge data set of cats. That's our real world data set. And we have a generator. So that's a neural network. It has to create images that look like the actual data set, cats. And there's this other stuff that is other neural network that is the discriminator. And if the discriminator can differentiate real images from the fake images, it means the fake images aren't really good. So the discriminator says, I caught you, this is a fake image. And then the generator can use that information to update itself to create even better cat images. And if the generator trains enough and everything is fine, then the generator will be creating images so lifelike that the discriminator won't be able to tell. And the implication of that is that the generated images are really, really good. So that's how generative adversarial neural networks works on the high level. And that's what we mean when we say adversarial neural networks, because the generator and the discriminator are fighting against it, trying to beat one another. Okay, so all this is new stuff. I don't know when these things will be used in the games industry, but I know they will, at some point, will be used in the games industry. So this is what we looked at. We can create, infinite number of human faces and actually blend in from one another. But I think even more excitedly for the games industry, we can create, oh no, it hasn't loaded. There we go. Yeah, this is a really good video. We can create stylistic human characters, human faces. And these results, I think, are game ready. I genuinely think we can have card games that directly use these outputs and call today. And one thing that is really, really cool in this specific project is you can both select the face, but also the different styles. So you can have the same face be drawn in different styles. And I find this incredibly fascinating. But we're not only limited with faces. We can actually create backgrounds. So on the left, you see what the artist has drawn or the person has drawn, and the agent takes in this very low fidelity, colorful paintbrush image, and then renders it into high fidelity renders. And then the artist can basically take that background and then build on top of it. So once again, this is not about a automation of AIs automation of artists, removing them from the pipeline, but rather automating the parts that are boring or less impactful so the artist can focus on the things that matter the most. So here, once again, the AI is given this, and it creates this lovely background. So why are we only limited to backgrounds? We can also create whole creatures. So once again, we give a color map to the agent, and then the agent renders it into a high fidelity image. And we can make changes on that level. So the colors actually correspond to different body parts of the agent or of the animal. So we can say like, oh, green is the neck, pink is the wings, and the brown is like spikes. So that's how it knows what thing to render those colors to. But see, you can easily imagine this is really useful in creating concept art incredibly fast. There's another way that we can help our artists, which is coloring black and white drawings. And this is also really useful in trying different color palettes. You give the AI a color palette, and it basically colors a black and white image using the color palette that you have. And the human can give more hints to work on it. Another way that we can use it is to relight paintings. So the artist has created a painting with a specific lighting condition, but maybe something changed, and we can immediately relight the painting using these techniques. And this is rather recent and incredibly cool. Now with these fancy new GANs and new techniques, we can actually generate a fully animatable 3D model from a 2D drawing. Here, a very crude drawing is done, and the person actually labels which one is on the front and which one is on the back, and voila, we have a 3D mesh that is easily animatable. And with just putting in a few keyframes and just moving the dots a little bit, we can get from that sketch to a character that is walking around. And it's really cool because we can add on textures and meshes on top of that to get rather cool looking, like usable end results. And this requires zero 3D modeling skills. And finally, well, not finally, but one thing that once again recently came up is a model that takes in natural language text, meaning just sentences, an illustration of a baby panda in a wizard's hat skating on ice, and then creates those illustrations. This is a very specific ask. A baby panda in a wizard hat skating on ice, creating an illustration. And it creates a lot of illustrations. Some of them are weird. For example, I don't know where the body of this character went, but some of them are basically passable. And this really opens up a new way of working. And you can even create full-on new art styles. So this actually runs in Unity, and this is a system called, or a technique called style transfer. You can give the agent a specific style, a painting, like Mango's Starry Night is a good example, and then it renders everything through that style. So if you want like a checkerboard style, that would be one thing, and so on and so forth. And this allows you to basically swap out and try out color palettes like incredibly fast, and this helps it iteration speed immensely. And yeah, so you can also use AI techniques to create new levels. This is Promethean AI, a recent company, and this is a recent keynote they have. You basically tell the AI to create a messy 80s bedroom, just that sentence. And then the AI looks at all the available assets that you have and then places them in ways that make sense. This system is incredibly cool because the interface between the human and the AI system is actually natural text. So you can give it statements and it acts on them. And as you can see, it has created a rather highly detailed, messy 80s looking bedroom. And you can move certain things, and then you can tell it fix the placement, and it orders and rotate things to match what you want. It's a pretty powerful project. I'm looking forward to seeing how this goes. And yeah, you can also generate music. So let's listen for 15 seconds once again. So what the system does is you give it one or two sentences of a starting music, and then it continues that music in the style that you give. So this is Mario level complete music in the style of Mozart. And honestly, this is not tomorrow of machine learning. I use this often in my game jams. It's really powerful. And one thing that I would highly encourage you to go check out is a website called AI Dungeon. You can go play.aidungeon.io to play it. It's basically a role-playing game that is powered by neural networks. So you will get some really funny situations, but I think it will be more impactful if you go out and try it. But among the art assets and the sound assets, the AIs can also be very powerful in generating new stories. And finally, you can use AI systems to create whole new games. This strand of research
Before we begin,
threatens me because as a game designer, I don't like it, but it exists. So my cook has a system called Angelina, and it creates and designs and creates fully playable games. And this research has been going on for, I think, almost a decade now. And if you want to be pedantic, this is not really machine learning, if I'm not mistaken. But then again, the system is really cool. So I wanted to share it with you all. All right. Okay. So up until this point, we looked at a lot of these new up and coming systems. And I think it would be good to keep an eye out on some companies because I think they'll be coming up with some really, really cool tricks in the near future. So obviously the stuff that I worked in, I'm a little bit biased. So Ubisoft Montreal, of course, does really good work. Game Intelligence Lab is pretty solid. And they recently released a research summit, AI and gaming research summit. All the videos are on YouTube. So if you're interested in these type of research and more applied stuff, you should check that out on YouTube. And of course, UnityML agents, because I'm biased. But stuff that I'm not affiliated with, one is Model.ai. So Model.ai is, I think, a consulting firm, and they're using these type of AI systems for game development. And they're really good in that they understand what the bottlenecks are. So they're using AI for cheat detection, I think, or outlier detection, game testing, and content generation, and then QA testing. So it's something that you should look into. And these companies you might work with in the future if you're interested in incorporating some of these ideas as well. Promethean AI, the artificial intelligence that builds virtual worlds, is the company that made the procedurally generated room. So it might be good to look into. They're rather active, and recently they released a keynote, a 50-minute keynote describing their whole workflow approach, and it's something to look out for. Really impressive work there. One company that I really like is called Spirit AI, and Spirit AI is all about language. They focus on natural language understanding, and they use it for both like story and text generation, but also to keep toxicity in games and under control for quality control in how your players relate to one another and talk to one another. Latitude AI is the company that makes AI Dungeon. So once again, another group that works on NLP. And Yuri AI is a competitive AI game company that makes competitive AIs. So they're using reinforcement learning, and they can basically integrate it into your own games. So if you want to, start incorporating some of the techniques that we talked about today, these might be some companies that you might want to reach out for. But then again, maybe you don't want to reach out to the companies and you want to get started by yourself. Cool, that's even better. So if you're a Turkish speaker, you can go to the blog and start with the blog post that we write there, which would be a repeat of what we talked today, but some more detailed context actually exists there. Blog, you can find them on these links. And also, if you're not a Turkish speaker and want to get a much deeper understanding of these concepts, I would highly recommend fast.ai courses. I think those are the most practical and applicable ones that will get you started really fast, and you will be building things incredibly fast. The practical deep learning for coders and the part 2 deep learning from the foundations are 2 courses that I think will be well worth your time. Then we actually created some some workshops in UNOG where we collectively went together these courses. And it was really fun. A lot of the difficulty comes from being alone in learning these things. So if you want to find a community to learn AI techniques, come join the UNOG and we'll help you out. And that's it. So thank you very much for listening to me, and I am open to your questions. Right. Let me stop sharing. Serdar, seni ben duyamıyorum ya. Acaba diğerleri de aynı mı?
I
Okay.
cannot hear you, Serdar.
For your presentation. So we have a question from Teoman Kerki. He asks, do you think that any limitations that we have in game development can be solved with machine learning in the near future?
Yes, I hope so. So I think, good question, Thelma. Thank you. The limitations will really depend. I think there's no one direct answer, but the answer can be seen in all the examples I gave. My intuition is that, let me see, testing is going to be one big area because testing requires a lot of manpower. Basically, big companies hire sometimes hundreds of people to just play the game and get some quality assurance, which means they have a lot of data on how to play the games. Which means we can bootstrap that data that is created and create agents that play the game, and that will release those people to do some more intensive and difficult tasks. So I think that would be my first bet into where these AI techniques will be most impactful in the near future.
Okay, so I have a question. So AI, the most oldest actually version that AI that I know is a chess AI developed in something 80s or 70s. I can't remember exactly.
Yep.
And right now AIs can create books, novels, music, many things, games, levels, dungeons, so etc. So should we stop at some point thinking about the artistry of making a novel, writing a novel, or making a game? Should we stop at some point on the AI level?
Yeah, that's a really good question. So there are whole books written on this topic, and it's fascinating because you can go either way. One answer that I can concretely give you is no one's going to stop. So there's so much economical incentive to not stop. That's not necessarily the conversation we should be having, I think. Instead, we should be talking about like, well, assuming we don't stop, because we're not going to stop, what should we do to protect what we have, the intuition. So policies that companies basically roll out or countries roll out is going to be very influential on like keeping income equality, but that's besides the point. Let's focus on the question of like arts and creating what you want. That conversation we kind of had back in the day where there were painters and being able to paint a realistic image was a big skill. And then photography came along and then suddenly that stopped being a big skill. And I think a similar shift is going to happen when AI techniques are much more thorough, where some of the things like creating a rather coherent text is not going to be rather difficult, but then coming up with stories that are worth telling is going to be places where humans are going to shine once again. So it's not going to break anything, but it's going to shift the landscape drastically, I would say.
Okay, thanks a lot. Do we have any other questions? I think we have not. Okay, thanks a lot again for joining for your presentation. Thank you very much. We hope to see you again joining us.
Thank you very much.